these are the answers for the second part of the asynchronous task. So here the reaction here is 2NaHCO3 forming Na2CO3 plus H2O plus CO2. Here the given are the concentrations at equilibrium of water, that's 1.15 times 10 to the power of 3 molar, and then the concentration of CO2 is 2.35 times 10 to the power of 3 molars. We're asked to determine the equilibrium constant of the reaction. So to find out the equilibrium constant, we can use the equilibrium constant expression. That's equal to, okay, so as you know, constant here is equal to the molar concentrations of the products over the molar concentration of the reactants. And as you see here, we have here solids. So again, pure solids and pure liquids are not included in the expression. So we're only going to use this one in the expression, and these are products, and products are in the numerator here. So we have H2O raised to the power of 1 because the coefficient here is 1 times the concentration of CO2, another product here, raised to the power of 1. It's supposed to be over the molar concentration of the reactant, but here our reactant is solid, and again solid are not included in the expression. To find out for EQ, we simply substitute the values of the concentration of H2O and then the molar concentration of CO2. So that is 1.15 times 10 to the power of 3. And then for CO2, that's 2.35 times 10 to the power of 3. And we can use our calculator to solve this one. So to solve for this one, multiply 1.15 times 10 to the power of 3 times 2.35 times 10 to the power of 3. That's equal to this large number. Let's express it in scientific notation. That's equal to 2.70 times 10 to the power of 6. 2.70 times 10 to the power of 6. This is the equilibrium constant of this reaction. Let's proceed to the second one. Here we have the reaction of nitrogen gas and hydrogen gas to form ammonia or NH3. So here the given are the concentrations at equilibrium of nitrogen and then ammonia, and then we're asked to, and also we have the given also is the equilibrium constant KEQ. We're asked to determine the equilibrium concentration of hydrogen gas. So the same thing, we can use the equilibrium constant expression to solve for the answer for this one. So that's equal to, again, that's equal to the molar concentration of the products over the reactant. So here, the product is NH3 raised to its coefficient. The coefficient here is 2 over the molar concentration of N2 times the molar concentration of H2 raised to the power of 3. Then after, we can plug in the given values for the KEQ. That's equal to 3.65 times 10 to the power of 8 is equal to the molar concentration of NH3. The molar concentration of NH3, that's ammonia. Ammonia, that's equal to 5.76 molar. 5.76 molar raised to the power of 2 over the molar concentration of N2 or nitrogen, that's equal to 2.56 molar. So 2.56 molar. Then we're finding for H2 here, H2 then cube. And then we can cross multiply this one. So we can multiply this one, then also multiply this one. So I'm going to multiply this one first. Again, I'm doing a cross multiplication. So that's equal to 3 times this one, okay, times 2.56 times H2 cubed equals to this one, 1 times 5.76 squared, so that's equal to 5.76 squared. And first, by the way, I need to solve this one. So what's the squared of 5.76? So 5.76 squared That's equal to 3 point, okay, let's use the whole number. We have 33.2, okay, 33.2, 33.2. Then I'm also going to multiply this one, 3.65 times 10 to the power of 8 times 2.56. So what's the answer here? Okay, that's equal to 3.65 times 10 to the power of 8 times uh, 2.56. Let's use the scientific notation. That's equal to 9.34 times 10 to the power of 8. Okay, that's 9.34. 9.34 times 10 to the power of 8 times this one, h2 cubed. And then to find out for h2 here, we'll divide both sides by this number, 9.34 times 10 to the power of 8, 9.34 times 10 to the power of 8. Then we can cancel this one. What's left on this side is h2 cubed, h2 cubed. Then let's divide this one, 33.2. So 33.2 divided by 9.34. 9.34 times, let me just fix this. So again, that's 33.2. 33.2 divided by 9.34 times 10 to the power of 8. That's equal to this number, 3.55 times 10 to the power of negative 8. 3.55 times 10 to the power of negative 8. And we're finding here for the h2. So we're going to remove this one. So we can remove this one by getting the cube root of both sides. Obviously, this will be cancelled. What's left here is h2. Then, what's the cube root of this number here? Let's use the other calculator. So here I have solved this one already. That's equal to 0.00329. Okay, 0.00329. So this is the uh, equilibrium concentration of hydrogen gas in this reaction.